Good evening. Our guest this evening to present our clinic is Tom O'Hara. Tom is a recent transplant to the Northwest from Midland, Texas. There he worked for some 40 years as a college professor in physics. I guess he got tired of that, decided to start playing with trains. In any event, he's ended up here in the Northwest, and we're very happy to have him. Tonight, he's going to discuss decoders and his approach to working on them. And I think you'll find this very informative. So Tom, take it away.
Hello, my name is Tom O'Hara. I got into working on trains back when I did my own trains, which I did for, I don't know, since the 80s. But at some point, somebody told me that I ought to work on other people's trains because there seemed to be an opening for it. So about 10, 12 years ago, I got into working on DCC. So I do a bunch of I've done a bunch of installations. I've done, I don't know, somewhere between 800 and 1,000. And then I work on some other things too, mechanical, because quite often the engine needs that too. But tonight I'm going to talk just about you might say, the hazards of doing your own installation, the rewards, but also what you need to go through to get there. Now, why do it at all? I got to open with that question because I know there's some people out there that are still in DC, and that's perfectly fine. They have essentially a block system, and they're comfortable with that, and I was comfortable with that for many years. The advantage to DCC, first of all, is that you don't have blocks, and you can have multiple engines running in the same track, which I love to do. That way you can run your yards and not worry about blocks. If you just do that, you can do it with just 4 wires. You need 2 wires to the track and 2 wires to the motor, and you're in business. Very easy. Now, you have skipped some of the nice things like sound and lights. So if you want to add sound, which at first I thought it was silly, nobody wanted sound, I was wrong. Anyway, you add a couple more wires because you've got a speaker in there also. So now you've got a couple more wires to keep track of. Finally, lights, headlights, backup lights. If you were in the diesel business, and I use that word very judiciously, you'd probably have little whirling things and flashing that and so on. But either way, that's going to get a little more complicated. So at some point, you're probably going to ask yourself, do I want to do this at all? And then you have 2 choices, and that's really to hire somebody or to do it yourself. If you do it yourself, you can cost of parts, you can get them from various suppliers, hobby shops. They all discount about the same, and I give the price there. And then if you're going to hire it out for the full Monty, lights and everything, it'll probably cost you considerably more. But how much is your time worth and your money worth? The first one is going to take you more hours because you've got to learn the tricks, and you're not going to learn all of them. Like I say, I've done 800 to 1,000, and I'm still running into difficulties and surprises that I wasn't expecting. How hard is it? I like to compare it to other things that we do in model railroading. I go to things, I see Propetrium mills. I think, how many hours did that take? I could do 10 or 15 engines in that time, probably more. Street scenes with all the little buildings and the people and the lights. And anyway, the difficulty is getting past the starting point, opening it up, finding out what's there, keeping it organized, and then you will be surprised that you can do it if you choose to. Or at least you'll know enough of what I'm going to say that you can ask questions of somebody that's going to do it for you. I list a couple of suppliers, but believe me, there's a bunch of suppliers. Just go on the internet, you'll find all kinds of them. So I'm talking to 3 people today. I'm talking about the person who likes DC, wants to stay there. Maybe he's got PFM sound. And then the person who wants to do it himself, and the person who's willing to get somebody. Before any of these people get carried away, they need to get their mechanical problems fixed. I always tell people, you send me an engine, check it out first, put it on get out your MRC power pack or something, or get one off the internet, and make sure it's running smoothly. If not, we're going to have a discussion about that when I see it, because DCC will not fix mechanical problems. It will give you an interesting running engine, but you've got to get the mechanical problems fixed first. Among them, now I'm back to person A. He doesn't need to worry too much about some things. I mentioned the LEDs because you can put LEDs into DC. You have to understand that they're not going to come on until you hit 2 or 3 volts, depending on the color, and that you won't have a light immediately when you first start cracking your throttle. Now, another thing though that I like to always point out to people, and let me grab a pointer down here. At this point, I need a pointer so that I can at least point to something. Right here, there's a little insulating patch. This is the left side, the fireman's side of an engine. This is the engineer's side. I've found that some people don't realize that everything on this engine is hooked to the engineer's side, except for these 4 tires. And that's because they touch the other rail. So you got to make sure that nothing on this side touches those 4 tires, including little pipes like these little pipes that run down. We call them sand pipes. Now this is an OMI engine, and these happen to be just, they're 3 dimensions up to this point, and then they're just soldered onto the engine. They don't come anywhere near the wheel, so they can't create a short circuit. On the other hand, this one over here has got 2 sand pipes running down. Somebody actually cut this one off because he probably got tired of it accidentally touching that tire and causing a short circuit. And after these things have been handled a bunch of times, I found out that I do it too. You bend them, just handling them. So if you need to watch out for these short circuits. I get engines sent to me all the time. The guy says it won't run, and all he's got is some type of a short circuit going on there. Another thing I'll just mention in passing, because I've run into it so many times, couplers. Couplers, I get them all the time that aren't the right height. And these are good engines, but look at the couplers, and they're not the right height. You ought to try and get those right, because particularly when you hit vertical curves or your track goes like, so it's the right height. So I'm sure of what I'm talking about. Anyway, these are just little things. They apply to everybody, but I'm pointing them out at this stage because everybody needs them, including Mr. A. Okay, here's Mr. B or Miss B. Wants to simply hire somebody. So why do you need to know anything about decoders, speakers, stay alive circuits? Why do you need to know anything about that? It's handy because when you talk to an installer and he says, well, do you want, it's nice if you know what you want. First of all, the simplest one is which decoder. I happen to do a lot of tsunamis. I've done others. I've done loc sounds. I've done TCS. The point, that's not my wow sound. My point is, look into it, read about it, find out what people do, and talk to people that you know. Why is this entire club using loc sound? Why are these guys all using tsunamis? Ask them. When it comes to speakers, my answer is the bigger the better, almost always. I like to get one that almost stretches side to side in the tender. And if I can get something into the engine where the sound would be better, it's nice, but a lot of time you just can't. And if you step back 3 feet from it, I strongly believe most people are not going to notice the location of the sound. Obviously, if you get 6 inches from it, because you want to just hear that thing yell at you, you're going to notice where it's coming from. I do use some of these, what they call sugar cube speakers. I don't think they're the best thing in the world, but I will definitely put them in there if that's what fits. But again, people have their own opinions, and naturally somebody who's selling these is going to have strong opinions. Anyway, ask, why do you need to see the inside if you're not going to build it? I just put this up here so you kind of know what kind of a mess is inside your tender, your goose, your shay. You can squeeze things in now that you didn't used to. That's a keep alive circuit, a speaker, and the soundtracks decoder. Here we've got lots of room. So if you're using a tender, usually you've got plenty of room, although sometimes the internal structure, like the sheet that wraps around a coal load, may be in the way. Anyway, why do you need to know this? You don't need to. But when he says, I can't put that in there without adding a load, I'm going to show you an example of this in a minute. Then that's because size is a player. And he can shoot you a few pictures of what he's done. Lights, how many lights do you want? What color do you want? People who want to put in gooses, geese, or 1910 engines may want to have a yellower light. You can achieve that. You can buy them plain whites, warm whites, and you can add a little Tamiya orange to make them this sort of a golden color, which I like and a lot of people do. But again, you could say, well, could I have this or that? Can I make the markers dimmer than the headlights? And the answer is yes to all of the above. What about connectors between engine and tender? You can hide these pretty well. You can't make them disappear. A lot of people want to put their decoder and speaker in the engine. If you do that, you're going to have to remove some weight most of the time, or you may be able to squeeze it in. But the advantage in that situation is then you have less wiring going from engine to tender. So again, knowing about this helps you to discuss it with the person. Okay, how about the guy who wants to do it himself, or you're already doing it? First thing I tell people is you need to know how to solder. This is something I've done in the neighborhood. I typically do somewhere between 30 and 40 solder joints in an engine. And the wires, this is the number 22 wire. That's the kind you use to feed your track with. These are all smaller, going down to a number 30. I think this is a 38. It's either 38 or a 40. But anyway, they get real small. And your hands need to be pretty good to handle these small things. I put the penny up here so you can get the idea. You're going to have to come up with a way to strip the wires, and there are ways involving heat, get your soldering iron hot or melt the insulation off there. You may want to use the liquid tape, that's a Home Depot type thing. Either for your insulation or just touch up your insulations. I mentioned Captain tape is something. It's a real good tape that we use. Doesn't leave a residue. It holds very quickly. A lot of people cringe when I say goo, but goo is still a good contact cement. You put a dab here and a dab there and let them sit for a couple of minutes, then you touch them together and the speaker hangs where you want it to. It's that kind of a thing. And of course, epoxies, most of you know about these. Connectors, you're going to have to learn. Here's connectors. And these things, this one right here is only about a 1/4 inch across. So like I say, it's small stuff. You have to kind of learn about it. Expect the first one to take a while. LEDs. This is the smallest size that is available. The numbering, you'll find on the internet, some companies call them nanos and picos and so on. That's a little bit more comfortable to some people, but either way, they're all pretty small. They all start off at about, well, the biggest one here is 800ths by 500ths of an inch. And the wires connected to it are probably number, I think 28 or 30, depending. The resistors can come in different sizes. When you buy LEDs nowadays, you'll see a lot of them brag that they come with a resistor. And everybody talks about the 1,000 ohm resistor. That's the one they put in there. 1,000 ohms on an LED is going to give you a brightness like a diesel headlight. If that's what you want, fine. If not, you learn about how to measure resistance and you put resistors in here. I never use 1,000 ohm resistors. I use something between 3,500 and 27,000 ohms for my resistors, and you'll still get more brightness than you ever had with a bulb. I suggest that you tie things down. A lot of these screws look the same. Some of them are and some of them aren't. But I don't always do this, but it depends on how many screws and so on. But tie them down, mark them so you can go back and find them again. And incidentally, I'm not reading all this to you because you can read it later on. I mentioned already about the isolation. Your engine is going to pick up off the right hand. This is the engineer's side. And your tender is going to pick up off the other side, the fireman's side. When you get to shays, they have a little bit different arrangement. Now, how do they pick up? They're just by metallic touching. So the tender is going to pick up from one side, the engine not the other side, and you need to make sure that they don't accidentally touch. But that was the same problem you had with DC. So you got to be careful with that. You'll find that there's a little, like some of these things have little plungers on these shay. And you can see the insulated side. This little plunger is picking up electricity from the fireman's side. Or little wires do the same thing. See this little wire going here? And I'm checking to make sure that that wire is touching that wheel. And that's what this continuity meter does. It's checking that because it may look like it's touching and it may not be. It happens all the time. And I get engines sent to me like this. You see the wire? It's not going anywhere near the tire. This guy was asking me, how come my engine doesn't run? And I turn it over. Well, what I did is I unscrewed these screws, bent the wires back where they're supposed to be, put it back together, and sent it back to him. Said, no charge, but this is the problem. Don't do it again or I'm going to charge you. And I never heard from him again. All right. So I'm going to very quickly run through an installation. I said, I need a rod engine. I didn't happen to have one in the shop right now. I had a whole bunch of shays for some reason. So I dug in my boxes and found an OMI engine, a really good looking little engine. And the guy gave it to me once upon a time as payoff on something. I never had tried it. I put it on the track and it drew 0.8 of an amp. Maybe you know your amps, maybe you don't. But this kind of, if this thing has a CAN motor in it, it ought to be drawing 0.1 amps, not 0.8 amps. So I immediately knew that I had a problem. I've got it sitting on a test track where I can measure the current and so on. You can do this on your railroad. Anyway, so I had problems. This engine was loaded with problems. The guy had poured glue on everything in sight to hold things in place. There was, I can't even tell you how much, half a tube of glue holding things together. I had to get rid of a bunch of them. That's not your problem. Okay, so pick which one you're going to start with. I tell people that the easiest one, if you happen to have a K27 hybrid sitting around, is it's about as straightforward as you'll find. Some of them are a lot harder. But anyway, if you don't have one of those, pick the engine you want. Okay, test it, find the mechanical problems. Remember what I said about finding the mechanical problems first. So I knew I was going to have to do some mechanical searching on this before I'd ever start trying to put a decoder into it. I have a test rig. I would strongly recommend if you're going to do 3 or 4 or 5 of these things that you get this because you can check your decoder before you put it in. And often that's really helpful because occasionally a decoder is bad. It's pretty rare, but they are. It's a lot easier to find it out here than here. And not to mention, you can play around with resistors and lights and so on. They cost $40, $45 from ESU. I mean, they're in the ESU brand and a Walk Sound brand. Anyway, I'm pretty fond of them. I have 3 of them actually. Okay, so I would say before you dive into the tender that you re-glue that coal load. All the time when I'm brushing it with my hands, coal starts falling off of there. So I re-glue every load that's a coal load with a little white glue or a little matte medium, whichever one's handy. Look for the chains. Some of these things have little chains that are supposed to help keep these things from turning too far on the reel. Those little chains are kind of a nightmare. Try not to break them. If you do it, you can fix them, but it takes some effort. Think about what color you want to make your LEDs. And I go ahead and put some super glue on the LED and let it dry so that it has two places where it's soldered on. The wires are soldered on that are metallic. I don't want those accidentally touching the engine or I'll get a short circuit. So I put a little super glue on them. Then this guy, which is me, I wanted these two to have golden white markers. So I dipped them in, to me, a transparent orange. I don't know why orange works so well, but I picked that up from off the internet and I get this color for it. And that makes my markers that darker yellow that I want. And I just put them in a holder and let them sit out there and dry. I do all this before I even dive into the engine. I put a little something here that you can look at in your spare time. This is a defense of why I say you don't need to use those 1,000 ohm resistors unless you want everything to light up like a church. I've also put several LEDs next to a penny so you'll see what you're dealing with here. Okay, so you open it up. Almost always on a rod engine, you'll find 3 screws, 1 through the front, 2 in the back. They may go down, they may come in from the end. I recommend that you find every wire that's in there and cut them and desolder them and just get them out of there. You're not going to use them. And they're in the way and you're trying to figure out how to use that. Not to mention, they don't have the NMRA color code. And the color code is real useful when you're trying to keep track of things. You may find some pickups that somebody put on there. They won't hurt, and they help get the juice from the rail to the bolster to the tender, and that's fine. But in general, you're not going to need them because keep alive circuits take care of them. Take apart as much as you feel like. Normally, I don't take it out all this way, pulling the trucks off, but sometimes you will. But keep track of it. I recommend you take pictures. When I started this, I was not so free with my camera. Now I shoot pictures of everything while I'm taking it apart because I know that eventually I got to put it back together. With this one, I found out the reason it didn't work. It had a bad motor. This motor, I think the guy got some of his pound of glue into the motor. But this thing drew 0.8 amps. This thing, under the same conditions, draws 0.05. 0.8, 0.05. That's quite a difference. So that was a mechanical thing I had to fix. Fortunately, the side rods, the gearbox is moderately good, so I didn't touch that. So put the LEDs in. You're going to have to start keeping track of wires. I strongly suggest that you put power to them. Now remember, with an LED, you can't put more than 0.3 volts if it's white or 0.2 volts if it's red. So make sure you get that series resistor in there. Then it'll be fine, whatever value. And you can play with the color. You can say, okay, this is too bright. I'll use a larger resistor. This is what it looks like before you start putting, this is what the LEDs in there. And here they are lit up. And you can see my markers are considerably dimmer than the headlight. These things can look like a mess. I just threw this out here. I'm not trying to confuse you. I'm checking to make sure that when I put the throttle forward, the engine goes forward. Otherwise, I'm going to reverse these 2 wires on the motor. It's a lot easier to do it now than to program it later on. I look it over, and that bit about, can I get a decoder under there and something over here? If I could, maybe I could squeeze more things into here. So you look at the space. Once you get it empty, you can start analyzing, where can I put things? This is what the tender looked like. It had stuff in there. It's the old PBL sound system stuff. It will start looking, it'll be fairly empty to start with. And then you'll start putting in a decoder and a keep alive and a speaker, and it'll start looking like kind of a mess. These 2 are both ready to be shut up. You just got to keep track of it. Think about what you're doing. Try and get the wires out of your way. I take a little bit of glue and stick them off to the side so that they're not in my way when I try and close things up. This is a Shay. Its wires typically come out underneath, but then they've got to get over to the motor that's over here. So I'm not trying to intimidate you. I'm trying to tell you, you got to be careful. And the color coding, like if there's a gray wire, it's got to go to the motor. If there's a purple wire, it goes to a speaker. I mean, that color coding is very important. You'll learn that if you play around with this stuff. Connectors. If you pick things just right, or you don't want sound, or you don't want lights, you may end up with just 2 or 3 wires going from the engine to the tender. On the other hand, this one's got all the bells and whistles, so to speak, and it's got 8 wires running back and forth. However, once you paint them black, things pretty well disappear, and they're not particularly offensive. You've got to decide that. I'm using a knife blade to separate these things because they are gentle. I have to be gentle with them. And I anchor them down with a little bit of caulk, bathroom type stuff. And then I plug them gently together, and then I work it apart with a knife blade. Okay, putting it back together, I'll let you read this. It's most of the time you're going to win. I strongly recommend that you test everything as you go, particularly the first time. Make sure that when you put power to that LED, it comes on. You put power to the motor, it goes the right direction. I'm going to just mention geared engines very briefly. The logic's the same. They just look a heck of a lot different. When you turn them over, they look different. You don't have an engine tender. They have a different set of wires. This is a 16-ton Shay. Its motor slides straight up towards us in this picture. This one's motor is over in here. Most of PBL's motors are in the 3rd tender nowadays, or in the second bunker if they're a 2-trucker. But anyway, speakers work under here if we put them in there, and that's nice. Okay, it can look like this before you start putting things in there, but actually that's got the decoder and the keep alive inside there. That's why there's wires running down. As I said, you can pack a lot of stuff into that 16-ton Shay. You can get everything you need in there. You just got to be kind of tight, kind of careful. And you see, there's that motor sliding in. You can get good sounding speakers in here. That's a double, what they call a sugar cube, to get more sound, and it gives you the 8 ohms too. I'm just going to throw it out geese. Everybody except number 6 is pretty easy because you got this nice big space. You still got to get wires up here. Number 6, you got to hide the load. There's just no way that you can get under that tarp that comes with it. So I always just build a little load for the guy, or tell him he can do it. I'll send him a picture and say, and then you end up with this. And you do end up with some nice lights, which is kind of fun. Okay, I'm about through. There's a learning curve. As I said, it takes 10 hours for me to do an engine. I don't do it all at once. I like to let the glue set move on to another one. But just be careful. Just be careful. Take your time. Take lots of pictures. Make drawings, particularly the first one, and you will survive this. And I have a phone number and an email. It's Tom O'Hara, and I will be glad to supply those if they don't come out automatically. So here's the end of it. And notice what you can do, how you can make nice little red light. Those are really red. For some reason, the camera didn't pick it up. So anyway, that's the end of it. I've enjoyed it. I hope that you got something out of it. I hope I haven't intimidated too many people, because it really is possible. Thank you.